Hello everyone. Today I'm going to start with algebra. So I'll be starting from the very basics. So this video is basically for the beginners who do not have any basic idea of algebra also. So you can also attend the video and we'll move from the basics to the advanced levels. So algebra. Okay. Now in algebra we'll have to understand one thing which is called as the variables. Okay. Which is called as the variables. Now what are variables? Variables actually are denoted by any alphabets. Okay, they are denoted by any alphabets which represent any unspecified value or numbers. Okay, so the variables are represented by alphabets. All right, and what do they represent? They represent the unspecified unspecified values and numbers. Okay, unspecified values and numbers. All right. And what are, as against this, what are constants? So constants is, most of you would already know, constants are those terms, okay, which do not change their value during the entire mathematical operation. Constants are basically the numbers. For example, let's say uh, 15, 20, 1, 2, etc. Anything, the numbers, they are the constants. Okay. Now that we have understood that what variables are and what constants are, we will move to the next. We'll step up a little and we will understand that what are algebraic expressions. Okay, we'll understand what are algebraic algebraic expressions. Okay, algebraic expressions. All right. Now, algebraic expression is actually a collection. A collection of what? It will have a collection of numbers, variables, operations, and grouping symbols. Understood? Numbers, variables, operations, and grouping symbols. Numbers are what? Numbers are basically the constants. So it will comprise of some constants, it will comprise of some variables, and it will have some operators with them to construct an entire mathematical expression, or what we better know as an equation. Okay, so an equation. So in simplified terms, we can say that algebraic expressions are nothing but algebraic expressions are actually equations. Okay, algebraic expressions are equations. Okay, algebraic expressions are equations. Now, uh, next thing is that how do we construct the algebraic equations? How do we construct the algebraic equations? Suppose I give you a verbal statement. Let's say the sum of 20 and a number n. The sum of 20 and number n. All right. This is also something which is very important for understanding your problem sums in algebra. Okay. Now, the thing is that when you are starting with algebra, you will be given mathematical expressions to solve. In those, what is it? You will be directly given the equation and you have to solve for it. Let's say that so solving algebraic expressions. Solving solving algebraic expressions. Okay, solving algebraic expressions. All right. Suppose you have been given an equation x squared plus y equals 5 minus of 21y. Let's say, and you are told to rewrite this equation in terms of y. Okay, in terms of y. Now, what does this mean? In terms of y means you have to isolate y from this equation. Okay, isolate y from this equation means that you have to take out y and keep it on one side of the equal sign. Okay, that means you are expressing y in terms of the other factors, whatever is present. Okay, so here, if you are expressing y, that is, you are making y as a subject. Okay, so y as the subject. How can we rewrite it as? We can add negative of y on both the sides, right? If we add negative of y on both the sides, it becomes x squared plus y minus y equals 5 minus 21y minus y. Okay, so this plus y minus y, this gets cancelled, this gets nullified, and this becomes 0, right? So we get x squared equals 5 minus 22y. Okay. Now, still our job is not done. So we had to express this entire, we had to make y as our subject. So if we are making y as the subject and we are isolating y, that means we will have to bring anything other than y on the other side of the equal sign. So whatever except y, what we have in this expression is 5. So what we do? We add negative of 5 on both the sides of the equation. If we do so, what do we get? We get x squared minus 5 equals minus 22y. All right. Now, still y is not isolated. What do we have with y? We have negative of 22. So what do? We will divide both the sides of the equation by negative of 22. So we get x squared minus 5 over negative of 22 equals negative of 22y over negative of 22. Now, negative of 22y divided of negative of 22, this becomes only y. And this side we have, if we take the minus sign in common here, we get 5 minus x squared over 22 equals y. Clear? I hope it is clear. It will be clear to most of you. Okay. So this is how you solve algebraic expressions. Now, the question which might arise to you is that now y is a variable, right? Because the value of y is not defined and y is an y is an alphabet, so it must represent a variable. Okay. So what is x squared? X squared is also a variable. Why is it that we have not added the two variables up? Now there is a rule for that. Okay, there is a rule for that. All right. That is defined by your variable operations. That is defined by your variable operations. Okay, variable operations. What is it that? Suppose, so what are the mathematical operations that can be carried out? At this level, you have four basic mathematical operations which can be carried out, correct? What are they? Addition, subtraction, multiplication, and division. So let me write here. What are the possible variable operations that can be carried out? That is, they are, first thing is that addition. Okay. Secondly, you have got subtraction. Okay. You can go for multiplication, or you can go for division. Okay. Now there is certain rules for the variables operations. Now for understanding these, let us consider two variables. Let the two variables be x and y. Okay, x and y. All right. So x and y, since they are two different variables, So if we are using two different variables, that means two different alphabets, that means we are representing two different variables. So if we are representing two different variables, then their summation, if we are doing, okay, this can add up. So we cannot further simplify it. Two unlike variables cannot be added with each other. Two unlike variables cannot be added to each other. That means what? X and Y cannot be added further. We can just represent it as X and Y. But if we had, let's say, X and 3X, can we add it up? The answer is yes. We can write it as 4X. Okay. Suppose we have X plus 3Y. Can we further simplify it? The answer is no. This is the this is the simplified version of it. All right. Suppose we had y plus, let's say 7y. We can write it as 8y. Okay. So the moral of the story is that if you have like variables, then you can carry out addition. Okay. Similar rules follow for subtraction as well. All right. If you have like variables, then you can carry out the subtraction operation. Suppose you have, let's say, x minus 3x. Okay, x minus 3x. So we can write it as, so basically how it comes is actually, so we have x common in both the terms of this mathematical expression. Correct. So what we can do is, we can take x common from both the terms. All right. Now, if we take x common from both the terms, then it becomes 1 minus 3. Okay. So 1 minus 3 is what? It is negative of 2. So we write it as negative of 2x. All right. Now, if you have to simplify this one, this also actually follows the same method itself. So I'm writing it here. So what we are doing is x plus 3x. Now, how does it become 4x? So x is present as a common in both the terms of the mathematical expression, right? So we can take x in common, okay, from both the terms here. So if we take x in common from both the terms here, it becomes x, okay, 1 plus 3. So 1 plus 3 becomes 4. It becomes 4 times x. Clear? Understood? I hope you have understood. Now, suppose there is uh, two unlike variables. Okay, there is two unlike variables. Unlike variables means what? Suppose you have x and y. Okay, suppose you have x and y. Okay, you have, let's say, x minus y. Can you further simplify it? The answer is no. This is the most simplified form. Okay, suppose you have y minus p. Can you further simplify it? No. Okay, but you have, let's say, 3p minus p. Can you simplify it? Yes, you can simplify and write it as 2p. Okay, now what is it for multiplication and division? Okay, so so out of whatever we have discussed so far, the conclusion stands that in case of addition and subtraction, we cannot actually, so two unlike variables cannot actually undergo addition or subtraction. But in case of multiplication or division, the scenario is a little different. Okay, the scenario is a little different in case of multiplication and division. What is it? Suppose you have to multiply two unlike variables, suppose x and y. Can you multiply them? Yes, you can. Okay. Suppose you have to divide a variable by an unlike variable. Okay. Can you do that? Yes, you can do that. Okay. So suppose you have here x times y. Okay. Very well done. We can do, so here I have used one term x square. You must have seen I have used one term x square here. So where does this x square come from? Where does this x square come from? X square actually comes from x times x. Okay, x times x equals x square. Okay, x times x equals x square. All right. So this is how is it x square? Just so this is the power one, right? And this is also, so only x means x is raised to power one. So this is also raised to power one. This is also raised to power one. So when we are multiplying a variable by the same variable, okay, or any variable with the same variable with a different power also. The powers get added up. So basically, in if you have done the exponents, you must have heard about the bases and the exponents. Okay, so if the base is the same, the powers get added up. Okay, if the base is the same, the powers get added up. All right. So here we get to see x squared. So similarly, suppose you have a times a, let's say to the power 7. So what will you have? It becomes a to the power 1 plus 7. Why? Because the base is the same. All right. In case of x and y, why did it not happen? Because the base was different. This happens, the addition of powers, this occurs only when the base is the same. Okay. Now coming to the last one, that is the division. Okay, that's the division. In division, what do you have? In division, suppose we are dividing one variable, let's say x, okay, by y. We can very well do it. Okay. Suppose you are dividing x squared by x. Yes. So here in division, what happens? In division, what happens? This powers. So in multiplication, what you saw? In multiplication, if the variables were the same variables, then what happened? They actually got they actually got uh, added to each other. But here what will happen is they will get subtracted. So we had x to x raised to the power 2. Okay. And here x is present in the denominator. Okay. So whatever variable is present in the denominator and the power of that variable, it gets minus, it gets subtracted from the one which is present in the numerator. Okay. And this gives you what? This gives you x. Clear? I hope this much is clear to you. So in this video, to summarize, I have discussed what? I have discussed about the uh, I have discussed about variables. I've discussed about constants. I've discussed what an algebraic expression is, how to solve an algebraic expression, and I have shown the variable operations. Okay. So based on this, I'll bring in the next video. Okay.